Hi, this is Mr. Tipton, and we are back today estimating and comparing some things with scientific notation. Estimating scientific notation is actually really easy. We're just going to round. We know that the first part of a number in scientific notation has to be a decimal that is at least 1 but less than 10. So we know that the decimal's over here on the right, and it has to move 1, 2, 3, 4, 5, 6, 7, 8, 9 times. But instead of, well, here, I'll write this down. So we know it's times 10 to the 9th. But instead of having to write down 4.237791286 times 10 to the 9th, if we're going to estimate, let's just use 4.2. 1 decimal point. That's good enough. Alright, I looked here, I wanted to round to this place, so I look one place to the right. It's a 3, so I round down. 4.2 times 10 to the 9th. Same deal here. The decimal has to go there. And I moved it 3 times to the right, so it's a -3. But I don't want to write down 3.45678 9. No, I don't want to do that. I want to round. I want to estimate. I want to make it easy on myself. So it's going to be 3.5 times 10 to the -3rd. I'm rounding to 1 decimal, so I have to look at the place to the right. 5 and above, give it a shove. Bumps it up to 3.5. So estimating's really pretty easy. Let's talk about comparing. The kind of comparing that we're going to be talking about in this video is determining how many times larger one scientific notation number is compared to another. This is how many times larger is 8 times 10 to the 5th than 4 times 10 to the 3rd. Here's the quickest way to do this. The easiest, I think, too. 8 times 10 to the 5th. And if I'm comparing, if I want to know how many times larger it is, really that's a subtraction issue, right? If if you have $20 and I have $10, you would say that you had twice as much as me. Okay. 20 divided by 10 is 2. Alright, 4 times 10 to the 3rd. We're going to do that with both parts of the scientific notation. How many times greater is 8 than 4? 2. And 10 to the 5th is how many times greater than 10 to the 3rd? Well, we're dividing. When we divide exponents with the same base, we subtract them. So we really have 10 to the 5th, the 5 minus 3. We're going to end up with 10 to the 2nd. Okay, 10 to the 2nd power is 100, and 2 times 100 is 200. So it's 200 times larger. Okay, so the regular number part I just divided. And the exponent part I'm dividing as well, but we subtract the exponents when we're dividing. 8 times 10 to the 5th is 200 times larger than 4 times 10 to the 3rd. Let's look at another one of those. How many times larger is 9 times 10 to the 12th than 5 times 10 to the 9th? 9 times 10 to the 12th over 5 times 10 to the 9th. Well, there's a couple of ways we can go about this. 5 doesn't go into 9 exactly. I suppose, if you got out your calculator, you would get 1.8 when you did 9 divided by 5. And then you'd have, times 10 to the third, because 10 to the 12th divided by 10 to the 9th, 12 minus 9 is 3. So then you have 1.8 times, oh sorry, that's scientific notation. I don't need that, I just need to move my decimal over. 1, 2, 3 times, and that gives us 1,800 times larger. But you know, I don't think I'd have a problem if instead of 9, you just went off of 10, kind of rounded up to a prettier number. 10 divided by 5 is 2, and you're still going to have 10 to the third. That the powers of 10 haven't changed at all. 2 times 10 to the third, 1, 2, 3, gives us a nice pretty 2,000 times larger. I would probably, if this was a test question, I'd probably accept either way. Just as long as you're showing your work, know where your answer comes from, and as long as your estimating wasn't, your rounding wasn't ridiculous. Okay, so a couple of ways to look at that problem when the 5 doesn't go into 9 exactly. Alright, that's pretty much it. Estimating scientific notation and comparing scientific notation, determining how many times larger one number is than the other. If you have questions, write them down, be ready to talk about them in class. We'll see you soon.